Hello, this is the luckiest maths teacher in the world. We look at algebraic fractions today. So we're looking at fractions with some letters or pronumerals in them. Now the idea here is that if it works for numbers, then it works for letters. And if it doesn't work for numbers, it doesn't work for letters. So we're going to apply the same processes as we would ordinarily when doing operations with fractions. So let's start off by looking at addition and subtraction of fractions. So you probably remember that you can only add fractions if they have the same denominator. Similarly, you can only subtract fractions if they have the same denominator. You probably also remember that when you're adding and subtracting fractions, you only operate on the numerators. Remember, numerators is whatever is on top of the fraction, denominator is whatever is on the bottom of the fraction. So when I say you only operate on the numerators, you only add the numerators or subtract the numerators. You never add or subtract the denominators. And you probably also remember that if you want to get full marks for questions, you have to make sure the answers you give are simplified, which of course means writing the fraction in its lowest form with the lowest possible numerator and denominator. So let's take a look at a question. So let's say I have 5a over 4 minus 3a over 4. So we're going to use the exact same process we would for ordinary fractions. So the denominator is the same, so I can subtract. So 5a minus 3a is 2a, and we leave the denominator as it is. But of course, 2a over 4 can be simplified because 2 and 4 share a common factor of 2. So I divide the top by 2, and I divide the bottom by 2. So a over 2 is in the simplest form. These two are equivalent fractions, but this one has lower number for its numerator and its denominator. All right, now let's look at another question. Let's say I'm doing a over 3 plus 4a over 9, okay? So in this case, I can't just add together the numerators because the denominator is not the same. So what I have to do is I have to find the lowest common denominator. It's just the lowest common multiple of the two denominators. So what I can do is I can times top and bottom by any number I want, as long as I do to the top what I do to the bottom. So I times top and bottom by 3, so then the numerator will be 9. I'm finding an equivalent fraction for a over 3 whose denominator is 9. So a times 3 is of course just 3a, 3 times 3 is 9. So I have 3a over 9 plus 4a over 9. Simple as that, that just becomes 7a over 9. Of course, sometimes you won't have one denominator as a multiple of the other. So let's say I have 5a over 6, and I want to add, let's say, 2b over 11. So for this, finding the lowest common multiple is a little tricky because 6 doesn't go into 11, 11 certainly doesn't go into 6. But what I can do is I can multiply top and bottom of this fraction by the denominator of the other fraction. And similarly, I times top and bottom of this fraction by the denominator, what's on the bottom of the other fraction. Now what this does is ensures that there is a common denominator. It may not be the lowest common denominator, however, so you have to make sure that you cover point 3 here, that you simplify your answers if necessary. So 5a times 11 gives me 55a, 6 times 11 is obviously 66, and then I get 12b over 66 again. So now I can just add the numerators together because the denominator is the same, and I get 55a plus 12 all divided by 66. Now I can't plus 12b. I can't simplify this any further because there is no common factor with everything on the top shared with everything on the bottom. There's nothing that goes into 55a plus 12b as well as 66. So that's adding and subtracting. So let's now take a look at multiplying and dividing. Okay, so for multiplying and dividing, the good news is that it's generally simpler than adding or subtracting. The reason is that we don't have to ensure that the fractions we're operating on have the same denominator. When we're multiplying, we just multiply the top and multiply the bottom. For example, let's say I have x squared over 9 times, let's say, 2xy over 7. Okay, I don't need to worry about finding the lowest common multiple of 9 and 7. I just multiply the tops together. So that would be 2, and then x squared times x is x cubed, 2x cubed y over 63. Again, I look and see if I simplify, but I can't because 2 and 63 have no common factors. So that's easy as. Now, for dividing, we can reduce division problems into multiplication problems, which is good since multiplication here was so easy. The reason for that is because multiplying and dividing undo each other. If I want to divide something by 2, I can just times by a half. So 10 divided by 2 is the same as 10 times a half. If I want to divide by 2/3, I can just multiply by 3 over 2. So I know you probably remember this from year 7. When you want to divide two fractions, you flip the second fraction and make it a multiplication problem. In other words, when you divide by a fraction, you're doing the same as if you were multiplying by its reciprocal. So let's look at a question. So we have two fractions and we are dividing. So what I'm going to do is I'm going to leave the first fraction alone, but I'm going to flip the second fraction, so change the numerator and denominator around, and then I'm going to change that division sign to a times. And now I just use the process I used in the previous question. So when I am multiplying with fractions, you have to treat expressions, so where we've got more than one term, as if they were in brackets. So I have to times 7b by the whole thing there. So the top would become 7b times a plus 7b times 3 over, so 10 times 3 is 30. Okay? Now, it may be tempting to cancel here, but we actually can't. I'm going to go through cancelling now, and hopefully you'll be able to see why we can't cancel this one. It is because there are no common factors. So cancelling is essentially just a way to simplify fractions. We're essentially dividing the top and bottom by a common factor. Now, I know you know how to do this, but we're going to look at some more complicated examples. But firstly, I want to explain when we can cancel. So let's say we have something like 4 plus 3 divided by 4. Now, you probably know that that is equal to 7 over 4, 1 3/4 or 1.75. But I can't cancel the 4's like this and say that the answer is 3. 4 plus 3 divided by 4 is clearly not equal to 3. So that there would be wrong. Now, the thing is, you can only cancel things on the top and bottom that are being multiplied. So we can't cancel, as in the question that I just did over there in blue, we can't cancel the 4 because it's not being multiplied, it's being added. If we had 4 times 3 divided by 4, then we can cancel the 4's. That does equal 3. 4 times 3 is 12 divided by 4 equals 3, okay? And of course, since we can do it with numbers, we can do it with letters as well. So let's say I had a squared over 16, and I'm multiplying that by 4 over a. So you can see that there are some common factors here. It doesn't matter if, say, the 4 and the 16 are diagonally opposite each other. I can still cancel them because 4 is being multiplied on the top and 16 is being multiplied on the bottom. So then I say, what is the common factor or the highest common factor I want? So 4 goes into itself once, so I'm dividing the top by 4. I must also divide the bottom by 4, and 16 divided 4 is 4. Similarly, I can divide a and a squared. They have a common factor of a. So a goes into itself once, a goes into a squared a times, so I just get rid of the squared. So now I've made the problem a lot simpler for me. On the top I have a times 1, which is just a, and on the bottom I have 4 times 1, which is 4. And this is as simple as it can get. Of course, this works in division problems too. let's say I had something like 7bc squared over 21k divided by 14b over 28k, something like that. I'm just making these up. So of course, what I do is exactly what I showed you before. I change the division sign into a times, and I have to switch the numerator and the denominator. Okay, so that's only one extra step, and now I do what I did in the previous question. So I have k on the top and bottom, so I can cancel that out. I have b on the top and the bottom, so I can cancel that out. It's a common factor. So 7 goes into itself once, and it goes into 21 3 times. 14 goes into itself once, and it goes into 28 twice. So this has made my calculations much, much simpler. On the top, I just have 1 times c squared times 2, which is 2c squared, and on the bottom, I just have 3 times 1, which is 3, and there are no common factors. But now I'm going to show you some really complicated ones. Please copy down this slide if you need it. So let's say I have to figure out this question here. Okay, so you will get questions like this. You've got some very complicated expressions in each of the fractions, okay? Well, firstly, we know that this is a divide question. So again, I can flip the second fraction and change the divide into a times, okay? But that probably still doesn't look like it helps that much. It still looks like a very complicated question. Now, what I could do to solve this is I could go ahead and times this by this and then this by this and then try and simplify, but that's going to take a lot of work. Whenever you get some complicated expressions like these, you get a question like this, your first thought should be, can I factorize? So if you can factorize any of the expressions, you may be able to cancel some common factors just like we've been doing. So hopefully after the previous lessons, you can look straight away at x squared minus 1, this one here, and say, okay, that's the difference of 2 squares. So that equals x minus 1 times x plus 1. Okay, now on the bottom is still x, can't factorize that. So x squared minus x, well, they have a common factor of x, so I can divide that. So then I just get x minus 1 in the brackets. And then on the bottom, x squared plus 4x plus 3 is, of course, a monic quadratic trinomial. So remember, we factorize that. We have 2 brackets. X goes in both brackets, and then we also put in the brackets 2 numbers that multiply to this number here, 3, and add to give this number here. So that's not too difficult. That's obviously just 1 and 3. So now that I've factorized them, I can cancel out a few things. So I see that there is an x plus 1 that occurs on the top and the bottom, and it's being timesed, so I get rid of it. I can do the same for x. And this is a lot simpler now. So I can just write x minus 1 times x minus 1, which is just x minus 1 squared, all divided by x plus 3. Now this is actually as simple as I can get. Please make sure you're not tempted to say cancel out the x's. Of course, I can't do that because the x's aren't being times, they're being added in each case. So this is my final answer. Still a little complicated, but it's a lot simpler than what we had up here. All right, hope you've enjoyed the video. This has been the luckiest maths teacher in the world. Have a great day.